they are. For commercial, they are not. So you have to read on there to make sure it's the right voltage. I have to make sure that only low voltage goes to this side. If I try to put high voltage here, even by accident, because people make mistakes, but on accident, if we put high voltage on the side of this, we're going to have a problem because this is designed for a 24 volt difference. So I'm going to show you what happens when we install this and we hook this up with high voltage. So I'm going to take my line 1 and line 2. We'll take it off of our transformer here. And I'm going to put 120 volts and connect it to this 24 volt transformer. Contactor. So I'm going to power this up and you'll see that it will pull the switch in, but let's see what happens after it does that. Okay, we have an electromagnet. Electromagnet's working, although we start to see a little bit of smoke. That's what we call the factory smoke. Once the factory smoke comes out, you can't get it back in. And if we wait, we end up with a nice little fire. Rapid oxidation. So if you were to install this incorrectly and just simply forgot, you end up with a fire. Now that fire could burn down a customer's house, and it has happened in the past. Think about everything you have in your house. Think about all the pictures that you have, your pets, relatives, losing every single thing you have. And imagine a guy coming out, well, I just mixed up 2 wires. It's no big deal. I did all the rest of them right. It's got to be 100% right. These wires that run down the wall, they can also become heat elements. These wires here can actually set a thermostat on fire. I've seen it before. So you want to make sure that you follow the schematic. Don't be afraid of electricity, but you certainly need to have respect for it all the time. And practice is how you get good at that. So this is just one example of how this is wired. We're going to add to this. It's not about memorizing these wires. It's about following a schematic. And that's what we've done is we've followed the schematic, and when we close the 24 volts here, this switch closes, low voltage load, high voltage switch. So it's action and reaction. So one other thing we want is anytime this switch closes, this load's going to energize. But what if we have another light bulb? So what we're going to do is then add another circuit. I'm going to shut our power off here, and we're going to add another circuit. We're going to take line 1 into a switch, out of a switch. We're going to go into a load. We're going to go out of the load, home to line 2. Now there's getting to be a lot of marks in here, but we can see that this is the only one that I haven't highlighted. So I'm going to start from this point. Line 1 is going to go into our switch. I'm going to grab another wire. Line 1 goes into a completely separate switch, not the same switch, a separate switch. In this case, we have an unused switch right here on the same component. So I'm going to go into the separate switch. And I've put that one wire on. I'm going to highlight this one wire. Now we're going to come out of the switch into a second load. So we're going to come out of the switch, out of the switch, into the load, into the load. Now that we've done that, we're going to highlight that one wire because we know that's done. Now after we do work in the load, we're going to go home to line 2, the opposite leg. So I went in this side, I'm going to come out of the opposite side, and I'm going to go home over here to line 2. So once we do that one wire, we highlight it. And now that we would see everything's highlighted. When you're doing this on a job, you'll actually have the wiring schematic. I use a highlighter, and you actually highlight the wire. When I'm using dry erase, I'm putting the lines beside it so it looks a little bit more sloppy than it would in the field. But it doesn't matter how many wires are on there or how many wires are here. If you follow them one at a time, you can see everything they go to. At the end, this will be covered in wires, and it doesn't matter. We've checked them individually and know what every single thing goes to. But I have this switch that's unlabeled. So this HR controls this switch. So this HR is also going to control this switch. So I know that if I put 24 volts here, this will close and this also will close. Sequence of operation: thermostat will call for heating, connect R and W, energize my electromagnet. My electromagnet will close this switch, sending power to this light bulb or heat element. Close this switch, send power to that light bulb or that heat element. So let's try this to see what happens. Thermostat calls for heat, connects R and W. Boom. Each one is controlled. Now here we just have light bulbs. I could put both these light bulbs to the same switch because they're just light bulbs, but I'm practicing for if these are heaters. If these were electric heaters, this would be about 20 amps it's pulling, and this would be another 20 amps that it's pulling. The problem with that's going to be, if I put both of these through the switch, that'd be 40 amps going to that switch. This switch can handle, say, about 25 amps. Every contact is a little different, about 25 amps. So if I tried pulling 40 amps through here, it would overload that switch. 20 amps is just fine. So each individual switch controls each of its own lights. I've only broke one side of the switch. I can put the switch on this side, I can break both sides. There's 100 ways of wiring it, but that's how this schematic is drawn. The other thing that we have is if we have our heaters running, so here's my heats running, I need to make sure that my fan's running as well. If I have my heater running and my fan's not running, all that heat's going to build up in that cabinet and it's going to trip a limit switch. Anytime I have a limit switch tripping, whether it's a gas furnace or electric, if a limit switch is tripping, you need to be thinking airflow, airflow, airflow. So I haven't drawn a limit in here, but we know that, hey, I'm running my heaters, but my fan's not on. And I don't have a fan wired in here. So we're going to add the fan switch to this. So I'm going to shut my power off here. Just going to add a wire to it. Line 1, we're going to take and go over here to a normally open switch. Then out of that switch, we're going to go into an inductive load, which is going to be these little circles, because it's an electromagnet. And then after we do work, we want to go home to the opposite side. So we're going to wire this just like it's drawn. Line 1. Start with line 1 again. Line 1 is going to go into a normally open switch. I'll use this one. Now that I've done that one wire, I'm going to do this one highlight. So we're done there. Now I'm going to come out of the switch into my inductive load, out of my switch into my inductive load. I've done that one wire, this one highlight. Now after I do work, I'm going to go home to the opposite leg, line 2. Do work, come home to line 2. And after I do that one wire, I'm going to do this one highlight right here. Now that's done. So my thermostat calls for fan, it connects R to G. Except down here we have nothing there. So we're going to have to add this. So our thermostat is going to have another switch, and we're going to have the letter G. G stands for indoor fan relay. That wire is going to go to a low voltage load. I'm going to call this FR for fan relay. We don't need this anymore. And after we do work, we're going to go to low voltage home. So we need to wire this as well. So we're going to leave the thermostat as the letter G. Doesn't matter what color that is, as long as we have the letter G. I'm going to use a black wire here. The letter G is going to go to our fan relay and do work. And I've done that one wire, so I'm going to highlight this one wire. And after we do that, we're going to do work. We're going to go to low voltage home. So after we do work, the opposite side is going to go to low voltage home, which is going to be right here. So now when I call for heat, my heater comes on. When I call for fan, my fan comes on. And if the thermostat calls for fan and heating at the same time, we'll be running our heat elements and our fan motor. The problem is there is still the possibility that when we call for heat, my heater is on, but the fan's not. So we're having all that heat built up in this furnace. It's not going into the house. We're going to overheat on a limit or cause a fire issue. So what we're going to do is add one wire to simplify all of this. So what we're going to do is have this wire come up to a normally closed connection. And we're going to connect one wire from the output of this heat sequencer to the input of the normally closed connection. So in this component right here, that we need to label FR for fan relay, this is all one component. If I look, I should have 3 wires. 1, 2, and 3 wires come into this. If I look up here, I only have 2 wires. So I'll need to add this one wire that's not highlighted. So we're going to leave our heat relay. So we're going to leave our heat relay. And we see there's 2 wires coming out of it. Now I have 2 wires coming out of it. Into my normally closed. Into my normally closed. That one wire is done. This one wire is highlighted. Let's double check my work. This component should have 3 wires, 1, 2, and 3. And we have 1, 2, and 3 on high voltage. Low voltage, 1 and 2. Low voltage, 1 and 2. So now, if I turn this on and have a call for fan, my fan comes on independently. But if I have a call for heat, thermostat calls for heat, connects R to W. I pass power to this heater. I pass power to this heater, and it goes through the normally closed connections, energizing my fan. And if I turn my fan on to the thermostat, it stays on. If I cycle it off, it still stays on because it's going through this normally closed. Let me show you what's happening. We called for heat. Now this close, this is doing work. This work closes this switch and this switch. So this light bulb's on, good. This light bulb's on, good. At the same time, we pass power to this fan. So on, and on. So we're set. If I cycle it off, this opens, this switch opens, not doing work. That means this switch opens and this switch opens. Electricity can't get to that load. It cannot get to that load. It cannot get to that load. If I energize the G terminal, we do low voltage work because this closes, which then closes this switch and opens this switch, and just my fan works. So you can circulate air through the house. If I kill this switch here, it opens, no more work. This switch opens, this switch goes back to being closed. So I'm controlling several things here. I got my W wire controlling both of these, and my G wire controlling this one. So now when my heat comes on, my fan comes on, it's a lot easier when you're here doing this. But this is just for tutoring for the guys that's been in class and want to see it again. So this is one way to control it. I can use a contactor. I have 2 switches, I have 2 loads. But this is not the only thing that we use to control heat. Some manufacturers use what we call a sequencer. A sequencer is a thermal time delay relay. So this is a sequencer right here, or a thermal time delay relay. This is going to be the low voltage. So on my contactor, these sides, oh, it's not coming back together. These very side parts are my low voltage. The sequencer, these very bottom ones, are my low voltage, and they are golden in color. Here I have 2 switches